Right, we're finally back doing videos again. First one of year 2010. So today we're going to talk about problem solving, because problem solving is a very important skill in maths and areas. Use a lot of problem solving. So we're going to look at some important points for problem solving if you're not already very good. The first thing is you need to understand what the problem is. That's the first thing you need to do. So you need to read through the problem, make sure you fully understand what you're doing, and then when you understand what you're doing, the thing you have to do next is you have to think of a plan. So thinking of a plan's kind of the hardest part, especially when you get further on in maths. You've come across more formulas and more techniques, and the problem is, how do you know which one to use? Well, there's some ideas actually. You can break up the problem into stages, which means you break it up into smaller problems and solve them, and use them to help solve the actual problem itself. And the other important thing is you need to identify what you're given and what you need to find, like the variables you're given and need to find in the problem. Sometimes it might be helpful to draw a diagram. So that's another good strategy. And then the next bit, obviously, is when you've thought of a plan, is to carry out your plan. And then you might think, well, you're done after that, but not really. The best thing to do is, after you've done that, is to go back and check your answer actually makes sense. Because if your answer doesn't make sense, then it's obviously not right. And then if it doesn't make sense, then you try a different plan and see how well that works, and then you check again. And then eventually it can get annoying, because you have to basically just keep repeating until you find a sensible solution, and then, you know, that'll probably be your answer when you get a sensible solution. Of course, if you're doing them from the book, you can check the answers in the back of the book. So I've got an example here. I haven't written it down because it's quite long and I've got a lot of the board full, so I'm just going to read it out to you from the notes. So this is what the problem says. It says, find the radius of a circle such that the circumference in centimetres is equal to the area in centimetres squared. So what that means is, it just means that the number is the same. So say it's 5 centimetres, 5 square centimetres, you know, they're both the same number, so that's basically just what it means. So we're going to look at with strategy. There's not really much to understand about the problem. That was the bit there I explained. That's stage 1 done. Next bit, we're going to think of a plan. Well, we're going to look at this here. Now we know some formulas. We know that the circumference, that's C, is equal to 2 times pi times the radius of the circle. We also know that the area is equal to pi times radius squared. So we've got two formulas, and we should also draw a picture here and know that this area around here is the circumference. It might not be right, who cares? I'm in a hurry. This here's the radius. This is the diameter. So that diameter is all the way across. When radius is just from the edge here to the centre. Sorry about that, I'm laughing because I know I've spelled circumference wrong, but English isn't really my strong point. Who cares? You know what I mean? Right, so we've done that bit. We've thought of a plan and we've done that. And we've drawn a little diagram there to explain what it means. So now we're going to basically carry out a plan. So, we're not going to look at pi because pi is just really a constant. It's approximately. That means approximately equal to rather than equal to, because obviously there's more decimal points, but you know, we're not going to write it all out because that'll take the whole board. So we're going to look at the other part. We're going to look at the 2r, not r squared. Now we should really remember some square numbers. 1 squared, 1, 4, 9, 16, 25, etc. We should remember them. And it's 2 times pi times the radius here, so if we times the radius here by 2, that means, and 2 squared is 4. So you see, if we've got 2 2's here, we can't really use another number, because when you square a number you've got the same number. But notice if we put a 2 here, it's 2 times 2, which is the same as 2 squared. So the radius we need is 2 centimeters. So we've carried out the plan. Now we're not going to have to keep checking again and do the annoying part, because I know that this is the right solution. But anyway, let's check just to convince you that it's actually right. So let's put r equals 2 into both of these formulas and just see what we get here. So that's going to be 2 times pi times 2, so that's going to be 4 pi, which is approximately 12 centimeters. We'll just say it's approximately 12, because that's what it is to the nearest whole number. Next one we're going to do is we're going to do this formula, pi times r squared. So it's pi times 2 squared, which is again 4 pi, which is approximately equal to 12. That's a centimetre squared because it's area. But you see, that's 12 here, the circumference, and the area is 12 in different units, but they're still the same number. Just want to let you know that a lot of other things in maths use problem solving in other areas like algebra, calculus, differential equations, and lots of applied maths. If you've never heard of some of those subjects, it doesn't matter, but I just want to explain how important it is. Just to show you that we've finished, we'll tick these. There we go. And that's the idea of problem solving.